Postgres is sort of this like giant, it's actually, I think, kind of like fitting, perhaps unintentionally, that the mascot is an elephant, right? Like it's this behemoth of a project. And it's been around, and it's been around for a really long time, and people really, really like it. And so obviously, right, like it wouldn't have stayed around so long if no one liked it. I mean, that's like, obviously there are lots of databases that people absolutely hate that have stayed around for as long or longer, but there are, it's that's for like vendor lock-in and like proprietary licensing reasons more than anything. Um, but Postgres like it's hard. It's like, I think that it's sort of important to like think about a lot because it's so big, and because you can sort of see the history of database development sort of in the thing that Postgres is. And from sort of lower level implementation things to sort of the things that people try and build with Postgres. And I think that's like a very fascinating thing. So I think a lot about Postgres, and I worked, and I did, though I'm not like someone who has like like Postgres isn't the sort of default database model in my mind, and it isn't sort of the, I think I said once, it's not the database of my heart, which is a weird thing to think about databases as, but I guess professional liability and all. But I have worked with it a lot. It's hard to avoid, and I've like worked sort of on it on a kind of sort of deeper level than perhaps I would even expect of myself. But there we are. And so I think that, so there's some like really interesting things to sort of learn about this, right? Like and I think Postgres, I guess there's like a couple pieces of this, right? Like, and to unwind a little bit, and drop some seeds that we'll probably pick up at different points. But data is the first sort of piece, is that databases are sort of fundamentally operating systems, which is a weird, they're sort of the what happens if you take a programming language implementation, a runtime, an execution engine, and an operating system, and push them all together. The query execution and compiler development are sort of the same problem in different sort of through different lenses and with different applications. Language design and query language design and improvement are fundamentally the same thing. The execution and optimization is the same sort of multi-pass intermediate representation, untangling and improving sort of thing, right? That's kind of the same problem. Databases, for a lot of reasons, like have to have a lot of control over storage, over memory management, and over concurrency control, scheduling, parallelism, those sorts of things. And they have networking on top of it. And these are all like, so if you have networking, you have memory, like memory management, and you're writing data to disk and you're in control of all of that. You do interact with the underlying operating system. There are like system calls that you're making, or through whatever wrapper, but really it ends up being, like databases will like allocate a big file, and then they're sort of in charge of the writing, managing the writing and the flushing of that of data to that file, and they sort of do that at a pretty low level in a way that higher level systems will just write sort of data to individual files instead of like having one big file. Databases often, will have to do their own buffer management and memory allocation. This is why, like, you see databases will sort of like allocate a bunch of memory and then just sort of hold on to it, even if the amount, like, because they sort of assume that they're the only application that's running on a system, and that once you should sort of like manage the memory and be in control of that, because putting stuff into memory is what makes databases fast, and which is the thing that reduces latency in a lot of operations. So all of these things sort of make databases an operating system project, and then you sort of say, oh, we have Postgres, which is 30 or ish years old, and you take that and you look at the other big operating system type projects around that are about that age, and you have this very short list that's like Linux and like like maybe we and FreeBSD and all of these. I mean, BSDs are a little bit older, but functionally they're sort of like the same generation of programs, and I guess there was networking in that last batch of features, but networking is a thing, and databases often have their own networking protocols. So once again, we sort of have this, like, databases are a microcosm of operating systems, and so like drawing these parallels of in development between Linux and Postgres is like a thing that I've been doing a bunch of recently, just because, like, thinking about like why does Postgres work the way it does? Why do the features get in that get in? What is the sort of, at some level, you like, it becomes like software development is a, particularly in open source, becomes like a political exercise. And so I think in both cases we have this, like, there is this sort of, like, to understand why Linux is the way it is, you sort of have to understand this, like, political history and the way that and the sort of way that Linux has developed over the last 20 plus the 25 years, and the same sort of thing with Postgres. Sort of seeing why Postgres is the way it is now has a lot to do with the politics behind it. So I think that that's been a big sort of thing that I've been thinking about, and I think Postgres, and so I like started this whole like long like diatribe about like why I like saying that I've like been working on this essay or hot take on why I don't like Postgres, and I think that the answer is not any of the things that I just said. Like, most databases like have this property. I think the thing that I find complicated about Postgres is that it's sort of on two levels. One, that it is as a sort of development framework, right? Like, Postgres is this database engine, and it has the storage parts, and it has the networking parts, and it has the query parts. And then sort of, if you're not doing sort of normal tables on normal sort of transactional workloads, you need a special kind of queries to run, you're immediately thrown into this execution or this extension system. And there are a bunch of, and like, Postgres has this active extension ecosystem, and extensions are great, and they're also, I think, a way to limit the scope of what like Postgres itself is responsible for, and so it ultimately means that like the thing that people mean when they say Postgres is the Postgres core and some subset of extensions. And a lot of extensions are really standard and normal, and maybe even, at least partially maintained by core Postgres maintainers. And then some extensions are elephants onto themselves, and it's, I think, easy to, and because it's an old program, extensions get dynamically loaded into the binary, which makes upgrading kind of dicey, and sort of means that any sufficiently big or unusual workload inside of Postgres has a bunch of dependencies on a subset of extensions, which means that the thing that you're running, the thing that is Postgres, is always a little bit different, and that's hard. It's a sort of hard to manage, and so that it's not a problem that there's extensions, but it does add some complexity, and you are running sort of like having arbitrary code running in your database engine, which makes Postgres a sort of the isolation and like the operational characteristics of Postgres, given the extent, like if you need extensions, really sort of means that you have to run Postgres in certain kinds of environments, and you have to manage the processes in a way which isn't as is much less like you have to, like, running Postgres even in containers is a little bit iffy because of its ability to code inside of Postgres can, like, in theory, escape given what is available via extensions. So with extensions, and that's just sort of an extra layer of sort of, like, if you're going to run it, like, if you're not using Postgres as a service, if you're not running Postgres in VMs, like in a thing like RDS, even operating Postgres requires a lot of sort of extra little bits to make work, and it complicates upgrades and all of that. And so I guess, like, all of that kind of like extension ecosystem and operations part means that, like, if you're gonna develop new database functionality on top of Postgres, say you wanted to have an analytics engine, but have it use like the Postgres query execution, or you wanted to have Postgres be able to connect to different kinds of data using the Postgres extension, you have this it's hard to sort of isolate the extensions from the rest of the thing that you're building, and you very quickly get into this is Postgres and this very unique bundle of custom code, which can change the way the rest of the binary works. It's Postgres is really is like has all of this power and is really battle tested, and it's you but you can sort of end up in these like little corners of you're sort of running something that's like Postgres-ish, and also you can't sort of keep the, like, if you sort of start to depend on your extensions for giving you new functions or giving you new data sources, you like the sort of maintenance path of that becomes kind of complicated, and the thing you're offering is less sort of generically understandable by people who just assume that it's Postgres. We've also had this, the other sort of end of this is that the Postgres as an API, like people trust Postgres, the query execution is indeed great. But if you, but it's also not as fully sort of specified or verifiable as you might want it to be. There, you sort of saying like, is this Postgres compatible? Is not a, there isn't a like set of queries that you can run to verify that something is fully Postgres compatible, because the thing that people are running to make Postgres is not, there's a superset of things, and people might be running any number of subsets of those. And we've had this problem or issue at ClarityB where we want to like provide compatibility with Postgres clients, but every Postgres client, in addition to speaking a specific wire protocol, has some expectations of what how Postgres should behave, and there's no place where you can read that all, and no test that you can just run. It ends up, for at least for us, like ends up being a very empirical kind of process. And I think that is true of sort of everyone who develops something on Postgres. And then you have, and so a lot of the end result of this is that whatever you're building with Postgres, you spend like this much time building whatever your sort of core interesting thing is: new storage engine, new functions, new or not storage engine, but like storage protocol. And so that's like a little bit, and then the rest of it is sort of managing all of the sort of baggage that comes with having 30 years of a single code base. And I think that like that means it's sort of an inefficient way to develop software, and means that you end up, the sort of amount of time it takes to build something in that is sort of disproportionate to the features that you get. You spend a lot of time and you get a few features and a lot of sort of Postgres management out of the way, and that's not great. And secondly, like the thing that you get for using Postgres really is this reputational advantage of, this is back to the politics, but like this reputational advantage of being able to say like, I'm running Postgres, this is based on Postgres. And I think that that's a very interesting thing, because the more you build on top of something and the more you load into Postgres, the less it is Postgres, right? That this like the fact that you can change so much of it, that Postgres can become sort of unrecognizable in all of this is really interesting. There's a right, like a lot of there's sort of always this like generation of things built on top of Postgres, and some really kind of intense and intensely cool industrial solutions have been built on top of Postgres and their products that people know and love and use. And I don't have the like, I don't want to like I have a list in my mind of things that I'm like, I'm pretty sure this is Postgres, or used to be, and this is Postgres or used to be at some level. But there is this sort of divergence at a point, and 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 that divergence sometimes, means that, so like there are some obvious cases like Aurora, the serverless Postgres, Amazon serverless Postgres product is Postgres, and is also like a custom build that they don't share. There are, or haven't historically shared. There are parts of that remain proprietary. So, is that Postgres? Yes. Is it really Postgres? It's hard to say. Like at what rate is the Aurora fork or build of Postgres going to track sort of the upstream line is hard to say, and it's hard to sort of bet on that. And I think that, and so like you building on Postgres gives you this big reputational advantage, and also it's very easy to build enough to become no longer Postgres, or to get stuck in some old version of Postgres, and that's unfortunate. Um, I think it changes a lot, and I think that having, and so like if you're building, I think that, so the conclusion that I've sort of come to over the last 2 or 3 days that I've been working on this is that Postgres is really a great engine for sort of conventional transactional workloads. Um, Small to moderate conventional, with sort of not non sort of steady consistent workload size, right? Like things that are very elastic and scale up and down. Postgres is, they're fine at, but like big sort of massive up and down kinds of scaling, you know there are limitations there. Um, like the transactions across multiple servers is not a sort of thing that I would go straight to Postgres for. But the truth is, right, is that there's most workloads don't need that kind of broad, really sort of transactional isolation across very big data sets, and even across small data sets. There are lots of cases where the sort of transaction parts are less, are like, people are used to using transactions to solve a number of isolation problems and concurrency control problems, but you don't need them as much as I think we're used to having them and used to using them to solve things. So I think that, like, generally, like, Postgres is great in those cases, and if you're trying to do something different, build a different tool, try different things. I think, while I really love Postgres for that transactional aspect of things, having it be the default engine for all databases or all data, um, is sort of a stretch. And I think a lot of like what we're doing at Rarity B is sort of a way of saying, like, let's use engines for what they're best at, and not sort of force Postgres to be your data warehouse or your document store, or I mean, it depends, right? Like, or a time series database, right? You know, there are extensions which do data warehousing, which do time series databases, which do other specializations of one kind or another, and I don't know if that's like the best answer to all of these things. It's debatable. We could have a whole nother debate of like, should you use Postgres for time series data? Should you use it as your data warehouse? No, but like a time series data is like a more complicated, and maybe a discussion unto itself. But I think like avoiding sort of this idea of enforced genericism. Databases often really want to be generic, and I think that this is the sort of like, maybe this is the sort of hook into the next thing, but genericism is I think a trap of product management, that we sort of say like, oh, this should be generic and we should let everyone use it, or like be the thing that everyone uses for all of their data needs. And that businesses like that because it gives you lock-in, and developers love making things as generic as possible. Engineers love making things as generic as possible. But it's not, but I don't know that leads to great user experiences, because it doesn't, because it's hard to do everything well. And also, while engineers really love building generic tools, it means that it's very difficult to make a decision if your use case is, we're going to be the generic tool for everything. How do you decide which thing to do first, or which thing is more important, or and if there are not just ordering prioritization problems, but actual things which are in conflict, how do you address that in a way that's reasonable? And all of those decisions are very hard, and just sort of saying yes to everyone, and saying like, oh, we'll put a configuration option to make you decide A versus B, is really pushing all of your sort of decision paralysis onto your users. So instead of you deciding that time series is a bad fit for your query engine, or documents are a bad fit for your query engine, suddenly your users have to make the decision that you couldn't for themselves. And that can be rough. It's also, it also can be rough for your business if you sort of abdicate lots of features. So it's sort of hard to, it's hard. There's no, I mean, like most things with computers, there's no winning. But we can get close, or we can get closer, or we can try and do better things. Certainly. So that's my sort of Postgres and database product rambling for the week.